everyone, welcome. My name is Krzysztof. Some of you may know me from a couple of USB related talks, so I may disappoint you. Today I'm not going to talk about USB at all. So if you came here to listen about USB, now you've got time to leave. If not, let's go to today's topic. During last year, I took a part in a project that the main goal was to keep Tizen as embedded Linux distribution up and running even when we accept some foreign code. Foreign code means that the developer is able to provide their own RPMs to the image, and we would like to make the user experience better. It means that we don't want crashes, it means that we don't want resource leaks. Our main target are long-running devices. It means IoT. So long-running devices are kind of similar to the servers. I mean, IoT is similar to server. They are all running pretty long. So to solve our problem, to keep our platform up and running, we try to learn from previous experience of server guys. Then we came up with our own solution because it turned out that solutions known from server world are too heavy for our small embedded devices. The whole Tizen image tailored for the IoT is up to 40 megabytes, so we would like to keep our solution small. The menu for today is the problem statement, the solutions known from the server world, our solution, some short summary, and question. So, what's the problem? To help you understand the problem, I would like to talk about California. Who have ever been in USA? Raise your hand. Yeah, quite a lot of you. Did you enjoy your visit? I have been a couple of years ago in California. It's a really nice place. It's sunny. It's beautiful. When I went there, I saw a lot of houses like this one. The house is big, but what focused my attention is this beautiful green lawn. I thought, California seems to be a rather dry place than wet. And to have a green grass, you need a lot of water. So I expected rather lawns like this one. So I thought, to keep this lawn green, they have to water it a lot. So it is costly. Then if you are doing this manually, it requires a lot of time. If you automate this, it may be beneficial, but you have to do some initial investment. So I talked with some guy from California. I asked him, man, how you are doing this? How you are keeping your lawns so green? He answered me, we are just painting them. They are just painting their lawns because they know that user experience is important. Their houses are like showcases. So when you come to someone's house and you see a beautiful green lawn, you know that this house is beautiful. When you see a lawn like from the previous picture, when it's really dry, you say, oh my gosh, it could do this better. And the same is with software. Our products are being bought using eyes, mostly eyes. So what's the most important is user experience, UI. But not only, because performance can influence your product and reliability. User don't want your device, your product to hang. He would like to move it smoothly. He would like your product to be ready to use every time. So how to do this? To ensure that your project is running smoothly, that your product is well recognized by user, you have to put some efforts into development. In our case, we are not providing a product. Our product is free. Our product is called Linux distribution. It's Tizen operating system. So, as I said, Tizen image is customizable. It means that you may log into the web server and choose which features you would like to include in your image. And then you may also add some custom RPMs. We don't know what you are adding to your image. We don't know what's your use case. We don't know if your code is of good quality. So, all in all, you end up with a platform where pieces of code comes from us. And we may say that they are pretty good, or they come from open source project, and we could say that they are really nice. And then we may say that you are uploading some foreign code, and we have no idea about the quality of this code. But in the end, you may always place a sticker on your product and say, hey, I'm running Tizen. It doesn't matter that to tens of our good services you add some crap. You may always say, I'm running Tizen. So the first piece of to have a good piece of code, you need to have a well-defined, a good software development process, like in open source. You've got code review, you've got tests. But there is a question. How long are you testing your product? How long are you testing your software? Are you testing your software running for a year? Not really. Usually you just run some unit tests and see, okay, it's working, so it should be working also for a year long. It's not always true. You need some continuous integration, and you need some static analysis to improve your code quality. But even if you put all the stuff in place, your code is going to be imperfect. Take a look on the Linux kernel. There is a lot of efforts, a lot of reviewers, but there are still bugs. It doesn't mean that you can throw the stuff in trash bin and stop using this. No, no, no. This is not what I'm trying to tell you. Please keep this in place. But remember that even if your process is really well defined, that you put a lot of efforts, your software may be imperfect. This means that it requires monitoring. And this is what server guys really know. So the second piece of code is the foreign code, the one you upload to the platform. And we have no idea if it has been reviewed at all. Have you tested or not? You are just uploading this to the image. So it even more requires monitoring during the runtime. So what kind of problems we may encounter? There are memory leaks, file descriptor leaks, bugs. In terms of bugs, I mean everything which may make your service behave unexpectedly, which may make your server crash. There are some boot loops. If you try to reboot your platform, then you may enter some boot loop. It's common, especially during updates, or many other. So it means that our solution has to be extendable to allow you to customize your monitoring infrastructure. So how to fix those problems in a runtime? So we may try to restart service from time to time. It's also a common practice from a server world that, my web server seems to be running fine for around a day, but then it starts using all the RAM memory. So how to fix this? Well, you should go to the code and fix it. But then you open the code base and you say, oh my gosh, it millions line of code. I'm not going to find a bug here. Okay, so let's just reset it every day. Then you have some fixed scripts, because services may also corrupt its data. So you have some simple fixer, not change inside the service code itself, but change some script that's going to fix the database or something. You may have the recovery mode. It means that you may have a separate initramfs where you can boot, and in some well-prepared, well-defined environment try to fix your problem. In the end, or maybe firstly, you should report the bug to the developer. It's important to not only restart the service, but also let the developer, the one who wrote this piece of code, know that, hey, you've got a bug in your service. You should try to fix it so we can upload the better version for the next release. And of course, any other method that you can think about. So, as I told you, keeping platform up and running is a well-known issue in server world. Those guys have really hard contracts for availability of their service, like 99 point and some number of nines %. So it's really hard to keep your service up and running for such a long period of time. So how they are doing this? The answer is monitoring and service restarting. The first method which helps us keep our service up and running is systemd. Who is using systemd? Yeah, just like I thought so. So it's common and it's almost free to use. Systemd provides two nice options to fix your service or at least to restart it. First one is the restart. It means that systemd is going to automatically restart your service based on the conditions you choose. The most common version is for long-running service, to restart the service every time when you enter failed state. Failed state, it means that it has been killed by the signal, it has exited with unclean code or something like this. The other method of fixing the service is to use on-failure option. On-failure is a unit which will be automatically started by systemd when a service fails. So instead of simply restarting the service, we are running some kind of fixing script or some kind of developer notification mechanism, something like this. But it's not enough for server guys. That's why there are some more extensive monitoring tools like Nagios. I think it's one of the most popular solutions. So the core part of this software is scheduler and web interface. Why we need a scheduler? Well, the very basic principle of Nagios is to run some script every 10 minutes, every 1 hour, or every minute to check the status of the service. We just check the status and collect the result in our database. If the service is failed, or for example, some server is not responding for the ping message, we are changing our state. There are 5 different states, and during this change, we are generating an event. This event may be handled by some event handlers. Usually, event handler is a simple shell script that is going to do the job. So for example, if you do the ping test of some server, you may try to handle the fact that it went from the OK state to soft critical. It means that server is down. So you write a shell script that is going to do the power cycle on the server to reboot it and try to keep it up and running, and obviously notify the administrator that something is wrong with that machine. The other way of checking the status is passive checks. In terms of classic plugins, I mean classic scripts which are checking the state, they are being run by the Nagios itself every n minutes. Passive checks are kind of different because it's independently running script or a service that submits the status when it would like to do this, or when the status is changed. So for example, if you would like to trace the amount of RAM memory used, but only with 100 megabytes resolution, you may report the status to the Nagios only when passing 100 megabytes of RAM usage, not every 1 megabyte change or not every 10 minutes. What's the disadvantage of active checking is that you have no idea what happened between the checks. So you've got a 10-minute gap for your measurement. Itzinga is a kind of fork of Nagios, and it has been created to be more distributed. There are multiple nodes set up, separate databases, etc. People say that they're both equivalent, but I think that this one is much more prepared for being distributed. But it's still very heavy. It provides quite a similar functionality. it has additional mobile client. So it doesn't matter for us because we are doing some embedded stuff. The next one is Zapier. What's different from our perspective is that it has much more events and it has a rule engine. In Nagios and Itzinga, you just say that if state of this check changes from OK to soft or to soft critical or to soft warning, then execute the script. Over here, you may write a rule that will combine status of multiple services, of multiple checks, and execute the script, for example, only if 5 or 10 services is done, not only one. So in Nagios, you have only piece of state, and here you may consider the state of whole system, of all checks. But it's still really heavy. So in general, server monitoring tools are really good. In addition, they are web scale, like the MongoDB. So it's a really good piece of software, but not tailored for embedded needs. That's why we just couldn't take it and fit this in your pocket. But we needed to develop something which is smaller. First of all, we did all those stuff as a central decision-making point. It may be distributed among multiple nodes, but all the devices, all the checks are being uploaded to some cloud, to some kind of central server. We don't want to make a decision about your devices. We don't want to collect your data. So we would like your product, we would like your service to be independent. That's why we don't want to keep the state on some remote machine, but on your product itself. So it's a single machine monitoring, no web interface, the delays should be low, and we should not set any pooling interval. So we focused on passive changes, for example, service failing, change of number of file descriptor or something, instead of executing the check every n minutes. Why? Because it's more power efficient to make the check only when the status is checking. We tried to make some measurements, and it turned out that most of our IoT devices are usually idle. So it means that they are in deep sleep state, and there is no point in waking them up every 10 minutes, or every 5 minutes, or every 1 hour, just to check the status which didn't change. So what we have developed? We created a FOSDEM. From our perspective, it's a generic event processing framework. It consists of single daemon, which has, as usual, input and output. Input is a change of state in the system. For example, systemd may notify us that some service failed. So this is our input. It's captured by some listener and reported as an event to the core. Every event that goes through the core is being saved into the database for further analysis. Then, we put it to the decision maker. What is decision maker? Decision maker is the business logic that decides what you should do in this case. It may contact the database, check the history. It may contact some external server. It may show user pop-up or anything, or send push notification to some mobile phone or something. It doesn't matter. FOSDEM has a plugin architecture, so you may write decision maker on your own. When the decision is made, so we now know what we should do. There are implementation of actions. Currently, we've got only 4 actions: restart the service, recover the service, reboot, and reboot to recovery. Because implementation of this action may vary between different platforms, between different devices, they are kind of abstract. So the business logic only decides what kind of action should be taken, and this part decides which implementation should be used. So what kind of listener do we have now? First of all, it's systemd listener. it's subscribed on private system dbus. Well, why? Why private? Because dbus daemon is a service. To be more precise, it's a critical service for our platform, because most of our services is using dbus for communication. So we don't want to get notification from systemd via dbus daemon. We want to get this notification directly. So we use the private systemd bus, which doesn't involve any other daemon for communication. So systemd may send us a signal whenever some service failed. When we got this signal, we are reporting event to the core and then run our business logic to decide what we should do with this service. Another type of listener is audit listener. Why we use audit listener? Because we would like to keep resource usage on, let's say, we would like to catch resource leaks, like file descriptor leaks, like memory leaks. So for every service on our platform, we set the memory limit, the max file descriptor limits, all the standard error limits. Then we use audit syscall to catch the moment when service gets some error message from a suitable syscall, and then we report this to the core and decide what to do with that service. What's important here that this solution is not perfect, because service gets an error. As you know, handling error in service, especially errors which are uncommon, like EM file. Who have ever get an EM file error in his service? Please raise your hand. Okay, so not so many people. So you see that it's not common. That's why error handling paths are not well tested, and usually they contain bugs. The perfect solution would be to get a notification that service hits some resource usage level without returning an actual error to the service itself. Apart from this, it turned out that for our platform, audit syscall is not free. It's rather expensive. Because if you use audit syscall, this slows down your open syscall for a 33% for a cold file and up to 45% for hot file. Hot file means that the file is already cached in inode directory cache. So that's why we developed error limit events, which are lightweight mechanism of notification to user space when the service reaches a given amount of resource usage. So we measured this, and it's 5.6% for hot file and 1.6% for cold file. Unfortunately, after I developed and posted an RFC, I have been moved to other project. So if there is someone who would like to pick up those patches, feel free to do this and try to mainline them. The next part of FOSDEM is decision maker. Currently, we've got 3 of them just for a showcase. First one is VIP process handler. VIP process is, for example, dbus daemon. When dbus daemon dies, there is nothing to do on this system. So it's time to reboot. The standard recovery means that if some service fails n times, it's being recovered. Recovered means that if it defines some recover script, we are running it. If not, we are simply restarting the service. After n times of recovering the service, we are doing n reboots. When we detect a reboot loop, we are entering the recovery and maybe sending some push message to the phone, hey, something is wrong with your IoT device, try to check it. The last one is decision maker for resource violation. Resource violation means messages from audit or from error limit events. If we detect that some service has resource violation, we may generate a report for the developer, send, hey, your service is using much more resources than you declared, you should take a look at this. And then we are restarting a service. Actions, like I told you. we've got recover the service. It means run the recovery unit and restart the service. Simple restart, reboot, and we've got 3 different types of reboot. The first one is forced. We just use the syscall. The second one is reboot using systemd. Once again, we use private bus to talk with it. And the last one is Tizen specific, because on Tizen, platform is being rebooted using device. Because the last one is not reliable, we are trying to use it, and then if it fails, we just go to the previous option. The last one is reboot to recovery. It's simply pretty the same as reboot, but with some special parameter, which make Tizen reboot in a recovery mode, the separate in from FS. The last part is database. Like I told you, every event is stored in the database. Why? Because FOSDEM is a daemon that is running as a root. FOSDEM is a daemon that is rebooting your platform. So, as a user and as a developer, I would really want to know who is rebooting my platform and why. So that's why we decided that every event, every action should be traceable from beginning to the end. So every event that is reported by our listener is as a trigger stored in the database. Then when the decision is made, it is also stored in the database, and the log from executing every action. So for example, we failed to contact device D and we are using systemd reboot or something like this, is also stored inside the database. This allows you to implement a decision maker which not only checks the current state of the system, but check also the previous action. So we can, for example, detect these reboot loops. Initially, for our implementation of database backend, we choose EJDB. It's kind of objective database without external daemon. It's really fast, but it turned out that it's not efficient in terms of storage. Not only in terms of storage for the database itself, because initially the database may be tailored to 1 megabyte, but the problem is that EJDB binary, together with Tokyo Cabinet algorithm which is used, takes around 700 kilobytes. And it turned out to be too big for our platform. So that's why we're switching now to SQLite, which is, let's say, the default implementation which we used was around 10 times slower, but after changing and tweaking the database schematic, we reach only 2 times, you know what. Sorry, I'm not native English speaker. Okay, so summary. How does FOSDEM itself look like? You've got the systemd notification, our input to systemd listener and to audit listener from the Linux kernel. What's important here is that before FOSDEM, we didn't use audit on our platform, so we eliminated the audit daemon. Why? Because it was slow, because it took some space, and because no one other used it. So there was no reason to keep it. We are directly listening messages from the audit. Then we've got the core part, which is simply a routing for the events, database, actions, and decision makers. So summary. What we learned during this year. First of all, server monitoring tools are really useful. If you've got your own server, try to install and play with them. There is a lot of benefits. You may see what your server is really doing. It's important not only in terms of kind of fault tolerance or painting your grass green. It's important in terms of security. Because, like my friend told me, in internet, there is no machines that does nothing. All machines which are connected to the internet may be subjected to attacks and be used, for example, to mine a Bitcoin. So if you are using IoT devices, remember to monitor also them. Because, you know the botnet Mirai? Who heard about it? Yeah, cool. So you know what you can use those IoT devices for. Unfortunately, those tools are too big for small embedded platforms. That's why we developed FOSDEM. We try to keep it generic, so if it fits your use case, it's great. Try to use it. It's available free and open source, available at jit.tizen.org. If it doesn't fit your use case, try to develop some plugins. It should be easy. Maybe it would be better than writing everything from scratch. The next one is that Audit Syscall is not free. Why it's kind of surprising? Because a lot of server is using Audit to trace activity on the server. But it turned out that on ARM platform, Audit Syscall is much slower than on x86. On x86, it's around 5 to 10%. So on ARM, it's at least three times slower than on x86. EJDB is pretty fast, so if you need a fast objective database for your platform, try to use it. Unfortunately, you have to have some spare storage for both library and the database. And that's all. Questions? Yeah? Well, FOSDEM is not using any distributed system. The goal is that FOSDEM should operate independently. It means that we don't want to have some central point of decision. We don't want to have some central cloud to collect the information. We want only reports about resource violations or about some attacks. But it's up to the manufacturer, because we are releasing this image. Yeah. What sort of things? Probably some kind of IoT gateways. But obviously it depends how you configure your image. That's why I mentioned that there is a web configurator and you can put anything on this. Some more? Yeah? We didn't need to handle C groups because C groups V1 already provided a kind of that functionality, at least in terms of memory C group. We didn't develop such plugin. We didn't develop such a listener, but we've been testing this for C groups. And like I told you, for the memory C group, there was a functionality similar to error limit events. It means that you can subscribe and get notification when C group is using some specific amount of memory. So it's really cool, but it has been dropped in C groups V2. Some more questions? Yeah? Am I familiar with Kiosk Monkey? No, I'm not familiar with it. Okay. Okay, so just to repeat, Kiosk Monkey seems to be a system that is randomly shutting down some servers just to check if they are able to recover. I'm not available, maybe I'm not aware of this solution and we didn't try to use it. Okay, thank you. Okay, so the question is if we evaluate money for this. We tried to evaluate money, but it also didn't fit. But I didn't mention about this because it's kind of similar to other stuff. So all the server tools are, let's say, common. They have some different features, but the overall idea itself is quite common. We don't have a scheduler here. We don't have active checks. We are using just passive checks, just signals from the system. Any other questions? if inside FOSDEM there is a kind of rule engine, well, yes. Because we've got the database, and every decision maker can contact the database and check the current state of the system. So, and not only the current state, but also we may check the history. So we may detect which time the service failed. Any other questions? Okay, if there is no questions, so thank you for your attention. Have a good day.